Hi, I'm Phil Bashurin from RightMaths, and today I want to show you how to use integration by parts with a few examples. My first one is to integrate x cos x, which is the product of two functions x and cos x. But according to the formula, I have to replace x with u and cos x with dv by dx. So let's do that first of all. So x is going to replace u, and du by dx we need to differentiate will be 1. dv by dx I replace by cos x. Notice that I do use dv by dx as the second function, and to get v I need to integrate it, so integrate cos x and I get sin x. All I need to do then is fill in the formula according to this. So it's u times v, which is x sin x, minus the integral of v times du by dx, which is sin x. Du by dx is 1, so I don't need to write that down, so dx at the end, so it's going to be x sin x. Now the integral of sin x is minus cos x. I've already got a minus, so that becomes plus cos x, and I need a plus c at the end, and there we go. Now on this second example, again I'm going to let u be something to do with x or x squared. The reason we do that is because it simplifies as we differentiate. We normally do that except in exceptional circumstances, and we'll come on to something like that in a little while. But this time we're going to let u be x squared, and we differentiate it to get 2x, and dv by dx is e to the x, and so v is also e to the x. So let's fill in first step of our integration by parts. So we need x squared e to the x minus the integral of e to the x times 2x. So I'm going to write 2x e to the x dx. Okay, so let's move on from there. We now need to integrate 2x e to the x. So let's do that. So 2x e to the x dx. Well, we're going to let u equal 2x again, and then it differentiates to 2, which is nice and simple. And dv by dx is e to the x, and so we integrate that, and we also get e to the x. So we can fill this in now. So we need uv, which is 2x e to the x minus the integral of v times du by dx. Well, du by dx is 2, and we times by e to the x dx, which is going to be 2x e to the x minus 2e to the x. So then if we want to fill the whole thing in, x squared e to the x dx is going to be, well, the first bit is x squared e to the x minus all of this, so it's minus 2x e to the x plus 2e to the x. Now I didn't put limits on this integral, but let's say I wanted to put limits in, so I'm going to go from 0 to 2 to log 2, and then we can fill those in our integral as well. So 0 to log 2. Well, this is going to be, I'm going to give myself a little bit of room here. X squared is going to be log 2 all squared times e to the x, well that's e to the log 2 minus 2 times x, which is 2 log 2, e to the log 2 plus 2e to the log 2, and then we have to take away what we get with the second limit. So it's 0, because x squared is 0, minus 0, plus 2 times e to the naught. What does that equal? Well, that's log 2 squared. Well, e to log 2 is actually 2, so I'll squeeze that 2 in there. Minus this again is 2, so I've got 4 log 2 plus 4, and then I have to minus 2e to the naught. Well, e to the naught is 1, so it's minus 2. So that's going to be 2 log 2 squared minus 4 log 2 plus 2. And there we have it. Thank you. Now, in this third example, I want to show you how to integrate log x. Log x isn't a product, and so it doesn't naturally fall into integration by parts, but it's a very useful trick to make it into a product of 1 times natural log x. Okay, and then we can use parts on that. We would normally let 1 be u, because when you differentiate it you get 0, and then that's easy to do, but that would mean that dv by dx would have to be log x, and we'd have to integrate that, and we don't know how to integrate log x. So instead, in this case, we're going to let u be log x, and we're going to let dv by dx is 1. Well, we'll differentiate it, so differentiating log x, we get 1 over x, and we integrate 1 and we get x. So when we apply parts to this, we get uv, which is x log x, minus the integral of v, which is x, times du by dx, which is 1 over x, dx, which is x log x, minus the integral of 1 dx, which is x log x, minus x plus c. So there we have it. We've integrated log x. Now, in my fourth example, I've chosen to integrate e to the x sine x, and I'm going to use integration by parts twice, so that's why I've set up 2 boxes here. Okay, so let's start. E to the x and sine x don't simplify when we differentiate them. So normally we would choose u to be something that simplifies, but neither of them do. So I can choose them either way round. I'm going to let u be e to the x. Let's differentiate that. That's e to the x again. And dv by dx is sine x. Now when you integrate sine x, you get minus cos x. So let's fill in the first part of the integral then. We've got minus e to the x cos x minus the integral of minus cos x times e to the x. Well, let's just simplify that before we go any further. That's minus e to the x cos x plus the integral of e to the x cos x dx. So I now need to integrate e to the x cos x, and I'm going to do that separately. So let's do that now. E to the x cos x. We've got to reassign u and dv by dx. U, I'll stay with e to the x, and dv by dx is now going to be cos x. When we integrate that, we get sine x. So let's fill in our integration by parts, it's going to be e to the x sine x minus the integral of sine x times e to the x dx. Okay, so when we look at e to the x sine x, then let's evaluate that. So I'll just come under the box. So e to the x sine x dx must equal, let's look at this, minus e to the x cos x plus this integral, which is e to the x sine x minus the integral of e to the x sine x dx. Now you'll notice that I've got e to the x sine x on this side, and I've got minus the integral of e to the x sine x on that side. So if I transfer this across, I get 2 times the integral of e to the x sine x equals e to the x times, I'm going to swap this around, just looks a bit neater, sine x minus cos x, and so I can then divide by 2, so e to the x sine x dx equals a half of e to the x sine x minus cos x. And of course I should put a plus c on the end. Okay, I hope you liked the video. If you did, then don't forget to subscribe to my channel, and also have a look at writemaths.com. Thank you very much. Thanks for watching. Bye.